we're going to take a look at systems of equations in 3 variables. Now we know that if we have a system of equations in 2 variables, we're talking about 2 lines, and if indeed they do intersect at a particular point, that's the xy coordinate point that we find. In this situation, we have a system of equations with 3 variables, and we're actually not talking about lines anymore. We're talking about a plane. And so the very first thing I want to do is to just show you how we would graph a plane on the XYZ coordinate, the coordinate system. So if you notice right here, here's the X axis. Okay, I'm not going to leave these colors on here. There's the x-axis. Okay. The y-axis is actually coming out kind of toward us. The positive side comes toward us. Okay. So they've kind of taken the xy coordinate plane and they've turned it down toward us. And then we actually have a z that actually is the height. Okay, so there's that. Now, in the same way that we would find the x and y intercepts for a line, okay, to graph a line in that particular way of graphing, we're going to find the x, y, z coordinate intercepts to graph this plane. So I'm going to first start with my x-intercept. And to get an x-intercept, back when we had 2 variables, we would set the y, we would make the y 0. In other words, make the other variable 0. Well, I do the same thing here. I make the y a 0 and the z a 0, and I find what the x-intercept is. Well, you can tell that that's just going to leave me x is 12. So I'm going to go ahead and put a dot right there at x is 12. And I've already counted those. Oops, excuse me. I've already counted those off, and that's 12 right there. And to the right is the positive side. So now let's go ahead and take a look at the y-intercept. And the y-intercept is when we would make the x and the z zeros. So you see clearly that the y is actually also a 12. So I've already counted, I think, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, I have. So I'm going to put that point right there on the y. And then lastly, let's get the z-intercept. Okay, and that's where we make the x and the y a 0, and we see what happens. So we have 3z is equal to 12, and z is 4. So my dot is going to go on the z at positive 4, and that's right here. Okay, so that's 4. And this is 12. And this is 12. So now all we're going to do is take the plane that is identified by 3 points, right? We must identify a plane with 3 points, minimum of 3. Okay, and there's that plane. Now that plane technically goes forever in every direction along that those 3 points. Okay, past those 3 points actually, 12, 4, and 12. Okay, so that's what we're looking at. We're looking at planes, and so now that we know what we're talking about when we say a system of equations in 3 variables, we're looking at planes, then now I want to take a look at solving a system that is an independent system. Now that just means that it's going to touch, it's going to have one point that is the solution, only one point. Okay, that's an independent system. And before I do that, though, I want to try to draw the picture of what that would look like. So let me see if I can get this on here for you. Okay, so that's my best attempt at drawing 3 planes that intersect in one location. Now I've put a black dot at the place where we would actually call the the actual answer, and so it's obvious. Whoops, easy does it. Okay, it's obviously the place where the red, the blue, and the green planes intersect, and so that's what we're actually finding when we find a system that does have an actual solution. So let's take, or a solution that is just one single point. So let's take a look at how we do this. And what I'm going to remind you is that you always want to have these variables in alphabetical order. Okay, it's just x, y, z. Okay, and the constant is always on the right side. So let's take a look at, oops, let me get this back on here. Let's take a look. What we're going to do is we're going to turn this 3 variable system into a 2 variable system. So what I do is I inspect each column, okay, the x's, I inspect the y, and I inspect the z's, and I'm looking for a column that I think would be easy to eliminate that particular variable, that particular column. So I'm looking at this one, and I think that probably combining the first and second could get rid of the x if I did a little manipulation there, and then if I combine my second and third, I could get rid of the x easily. And what I would have is a 2 variable system with y and z only. So let me show you what I mean by that. Let's take these two down here, and I'm going to recopy them. I'm going to copy the top one. And now what I'm going to do with the second one is I'm going to multiply the second one by -2. Okay? So I'm multiplying by -2. So here I go. So a -2x. So this is what is being done to this equation right here. And then I'm going to have a positive 4y there. And I have to do it to both sides, right? So then I have a -2z. And that's equal to, this right here is also going to get multiplied by the -2, right? Multiplied by -2. And so that's going to give me an 8. Okay, so I'm going to go ahead and add the columns, and that's just like adding like terms. We're actually allowed to add equations together. And so I add this column, and that goes into nothing. I add the y column, and I get 8y. I add the z column, and I get -4z. And I add that, and I get 12. Okay, so I'm going to let that kind of be on hold for a minute. So I have 8y minus 4z equals 12. Now I'm going to bring these two right over here, okay, these two equations. I'm going to go ahead and just write them as I see them. Whoops, I meant to do the first stages in this blue. So here we go, x minus, 2y plus z is equal to -4. Now, remember, I've gone back to the original. I'm not multiplying that second one by anything. I'm just writing it. I've already used that process on the previous one. So there's -2. Okay. So now I'm writing these. I'm taking equations 2 and 3, and I'm combining those. So let's see what we get. Okay, so I take that column, and it goes away. I have a positive 1y. I add this column, and I get a -2z, and that's equal to a -6. Double checking my work, and I believe that's correct. Y minus 2z is -6. Okay, terrific. Now what I'm going to do is I'm going to take these two equations, okay, these two equations, and I'm going to stack them on each other. Gosh, what is wrong with this? Just a second. Okay, I'm not sure why that was doing that, but we'll move on. Press on. Here we go. So now I'm going to have my 8y minus 4z is equal to 12. There's that one. And now I'm going to go ahead and y minus 2z is equal to -6. So now I have a system of two variable system. And what I think I'll do is go ahead and multiply this row right here by a -8. So I'm going to multiply that by -8. And let's see what we get over here. I get -8. You know what? I'm not going to do that. That's not what I did on my before. I think I'm going to just multiply that by a -2. Let's multiply it by a -2, okay? That'll make it a little bit easier. We'll have -2y plus 4z, and that's going to be equal to, multiply this one as well by -2, and that's going to give me a 12 there. And let's see what this is, just copying this, minus 4z, that was what my plan was. Okay, here we go. Let's add the columns together. We get 6y. This column goes away, and I get 24. And I get, divide by 6, I get y is 4. Now there's one of my 3 answers. Now let's think, what would make sense okay, to bring the y that's 4 back to one of the green two-variable equations, doesn't matter which, and let's go ahead and substitute the 4 in there and see what z is. So here we go. I'm going to just write the easiest one I can see. Y, goodness. So this is going to be putting in the 4, and use the bottom equation, minus 2z is equal to negative 6. Let's see what we get. So minus 4, so negative 2z is equal to minus 4, negative 10. Divide by negative 2, and I get z is 5. There's the second of my 3 answers. And then what makes sense is to go ahead and now take this green one back to the blue original equation, either one of them, right? Either one of, excuse me, I'm going to bring it all the way back to this original. I'm going to go ahead all the way back to the top. 2x plus 4y minus 2z. 2x plus 4y minus 2z. 2x plus 4y, notice I'm substituting in the y, minus 2z, let me make sure I wrote that top one correctly, is equal to 4. Okay, so I'm bringing it back into the original one up there. All right, and let's see what we get. 2x plus 16 minus 10 is equal to 4. 2x, that's going to give me 6. Plus 6 is equal to 4, minus 6, so I have 2x is equal to negative 2, and I get x is negative 1. There's my third of the 3 answers. So here's how I write my solution. My solution is a set, and it is the point. Negative 1, oops, put them in alphabetical order, right? X, Y, and Z, and then that. Negative 1, 4, and 5. Okay? That point, if I take each of those values, that for x, that for y, and that for z, and I put them back in all 3 of my original equations, they will actually prove to make the equation true. Okay, so that's basically my black dot. This right here is my black dot that I showed you on the picture. It's the place where all 3 of those planes intersect. All right, hope this was helpful. Thanks for watching.